Okay, so they're asking us to figure out the standard free energy, that's change in G. They're asking us to do it from a set of tables. And what we know for a fact is that anytime that we have a change in G for a reaction or change in anything, it's always the products minus the reactant. So I'm going to write change in G for the reaction. Wouldn't that be the sum of all the changes of all the G's of formation of the products minus the sum of all the G's of formation of the reactants? And you should probably put an N in front of this in case you have any coefficients in your reaction, and you do right now in this particular problem. So if you take a look over at our equation, our actual equation, we have CCl4, 1 mole of it only, but over here we have 2 moles of Cl, 1 mole of C, and they're being added together. So let's start with our products over here, because we always start with our products, and we're just going to write change in G is equal to, and now we're going to add up all of our products. Now, when we look on our magical table, it tells us that we have minus 64 kilojoules for the change in G of our products. The coefficient right here is 1, so we don't have to worry about an N value here because it's just one of them. So that's our products. And then over on our reactant side, we have two things. And I don't want to spoil this for you. And if they'd want to make the problem more difficult, they could have. But do you guys remember how when we talked about the enthalpy of formation of something, how the enthalpy of formation of an element was always 0? Well, the same thing works when we're dealing with the change in G of formation of something, of an element. That's equal to 0 as well. So what we have on this side is we're going to subtract these two things, but both of them, if you look at their free energy formations, it's 0 plus 0. It does not get much easier than that. If they'd actually given us values that were not elements to begin with, we would have had to find them on a table and then put them into these spots here and here. But they didn't. So we're just going to go ahead and go, thank you very much. Negative 64 subtract 0. Our change in G for this reaction is going to be negative 64 kilojoules. And we are done. I'm not going to write it up above there because my handwriting is terrible, but this is going to go into here, and we are finished with our problem. Hopefully this has been helpful.